So how'd number 9 go?
That was light.
Is there anybody that can't do this? I will be glad to walk through the steps. Okay, so Venetia wasn't here, so this is a good time to just walk through this. This is the same as this. I know, give me 1 second, guys. We're dividing by this factor. This factor, when we set it to 0, tells me I have a root of -3. Yeah, or I'm just dividing. In our case, we're just dividing. We're going to find the difference between the roots and dividing. We're going to see that this over here, when it's 0, it actually was a root. Give me 1. All right, so now, if we end up with something other than this, then it's not a root. It's a regular divide, and we have a remainder. So we can divide these things out. We take your leading coefficients all the way down. You have to account for every position. 2, 10, 12. I have x2, x1, x0. This is an x0. x0, anything to the 0 is 1. So we're going to divide by, set this equal to 0, -3. And we have a pattern. Bring this down. We multiply and go to the right. -3 times 2, -6. Add down. God bless you. -3 times 4, -12. Add down. We're going to see that if that's a 0, we actually found a root. If it's not a 0, we have a remainder. How we get this is by looking just at the front end again. Just say it real simple. I have x2 in the numerator, x1 in the denominator. So my result has to be x1. Then this is x0. So I write this 2x plus 4. This is my answer. If I had a remainder, I'd say plus my remainder over x plus 3. But since I have a 0, I don't have a remainder here. Okay? Take a look at another one. Okay? How'd this one go? And when you pull out your coefficients, run them through. x4, x3, x2, x1, x0. Make sure you go down to the 0. Because if you miss a space holder and you go through the whole thing, you got to do it over again.
For where the 0 is, there's no x?
Right. This would be x3, x2, x1, x0. God bless you. So this kind of takes that one away. You could put 0, x1, but anything multiplied by 0 just wipes it out. So we set this equal to 0, and we find that x is -2, and we follow. Pull the 1 down, multiply to the right, add down, multiply to the right, add down, to the right, add down, to the right, add down. This one came out with a 0. That means that this guy was a factor. If I took this answer and I multiplied it by x plus 2, I would get back to what I started with. Now, when we do this, we had x4 divided by x1. Alicia?
Oh, no.
Oh. We had x4 divided by x1. We start with x3. x3, x2, x1, x0. So the 0 term is just going to come out. So we have x cubed plus 3x squared minus 1. That's our answer. Ethel?
If the root was to the 5th, and it was like x3, x2, and where the 0, it was x1, or x2, and then the other one where 1 is x0. Wait, I just got this one. Sorry. If it was 5, and where the 0 is, would it skip over to the next number, or?
We'll fill all the positions. We'll fill them all. If this went like this beginning went like this. Is this what you're asking?
No, it's the same thing, except instead of a 4, it'd be the leading, the x4, it was x5, and in the bottom, when you already have the
Okay,
x
then
there.
this would be x4.
Yeah, where the 0 is, would the x go to the next number?
Well, we would have to redo this whole thing. It would still make enough positions on the bottom to start at x4 all the way down. And then you'll see when we do a bigger one, it stays in place. It always stays in place. And then you just run them all the way down. So it will take care of itself when you have another position.
No, but what I'm talking about is where the 0 is. If it was like x3 where the 0 is, would it still be no x, or would the x3 go to the negative 1?
If this was at the 4,
Mm-hmm.
then the 3, then the 2 would have no 0 in it. The x2 would have no 0 in it. It would be not there. Yeah. Does it make sense? Okay. Okay. All right. So I didn't give you this one, right?
I did.
No, I did?
Yeah,
I gave you this one?
for the first 4.
Ah. Okay. We'll come back to this one. Okay, let's go to number 15.
Wait, did we do number 13?
Yeah, I'm passing it. We'll come back to that. I didn't think I gave you that one. That's probably why you couldn't do it. Okay, now, notice, there's no x squared, there's no x1, this is x0. I have to put space holders in there. So I have a coefficient of 7 for my x cubed. I have nothing for my x squared. I have nothing for my x1, and my x0 is a 3. I have to have space holders. When I count down 3, 2, 1, 0, I have to be able to count from the highest down to 0. And then I divide by my negative. So I bring this down, follow my routine, multiply. x3 over x1, I'm going to start with x2. x2, x1, x0. This guy is my remainder. So my answer has to look like this. And I usually like to put it in parentheses. Minus 53, this is my remainder. Just like we did yesterday. Okay? Okay, let's go back to number 13. Feel bad because I didn't show you how to do this one yesterday. Okay, you're going to pull out your coefficients. 4, negative 7, negative 11, 5. 3, 2, 1, 0. Now here's the problem. You're dividing by 4x plus 5. We always use the last two terms and set that equal to 0. However, just like you did when you were completing the square, the leading coefficient has to be 1. So we have to factor out a 4. Oh, we did this. We did one yesterday with the factor out, right?
Yeah.
We did. Okay, then I don't feel as bad now. So we have to factor out the 4. When you factor out the 4, yeah, you are left with a fraction. We're going to circle this 4 and remember to come back to this. Okay? This is the hardest part. We have to remember to come back to that. So now, I set this equal to 0. And I get x is equal to negative 5/4.
Oh.
Okay? So I'm going to divide by negative 5/4. Usually these things work out. It's very rare that you see fractions in your quadratic, in your polynomial equations, right? It's pretty rare that we see fractions at the end. So they usually work themselves out. So when I multiply negative 5/4 by 4, my 4 comes out. I'm left with negative 5. I add down. I multiply negative 5/4 by 12. Then I get positive 15. I add down. Again by 4, I get negative 5. I add down. No remainder. Now, at this point, if I did this, if I said this is 4x squared minus 12x plus 4, and I was going to multiply this by 4x plus 5, does that make sense? 4x times 4x squared, do I get 4x cubed? No. So that tells me, oops, you forgot to divide by 4. You factored out a 4 here. You have to factor out a 4 here. Can you do it after you set your x's? Yeah. It's probably easier before, but if you prefer to do your x's first and then divide, that's fine. Divide these out and then put your x's here. Because now, if you just look at the first term, watch. I don't need you to multiply the whole thing out, but watch. Multiply your first terms. What is x squared times 4x? 4x cubed. Wasn't I supposed to get back here? Now multiply your last one. What is 1 times 5? 5. Ah, didn't I get back there? Usually if your first term and your last terms are okay, then you're good. Now sometimes, of course, if you have a remainder, when you multiply your last terms, they're not going to match until you add your remainder back in. Which makes sense, right? Okay. Now,
The answer is, wait, what's the answer?
your answer is this.
So when you get, after you synthetic divide, whatever you get, you divide by what you factored out.
Which you factored out. Which is why I say circle it or star it, because I myself forget. After you do all this work, you're so used to following your routine. Okay, now let me put my x's back in, that you forget unless you do a front end. Always do a front end check. A front end check is your easiest one. Take whatever you started with times what you first divided with. That's got to come to the first one. Okay, so same thing like when you're factoring. Sometimes you factor, you get the wrong factors, and I say, is this possible? Like 2x times 4x equals 2x squared. It equals 8x, because we forgot to factor out something else. So always go back and check. And this is a good one to catch your mind with that. Okay. Let's take a look at one of those last three. We only had 2 more?
Yeah.
Okay. 19. Let's hit 19. All right, let's hit number 19. We're going to divide this. Everybody divide this with me. X cubed minus, you don't have this one?
No, you told us not to.
No, we're going to do this together. Do you have this on your paper?
Yeah.
Okay, let's divide this together. Now, same thing with the bottom. I'm missing a term in here. What term am I missing? X. So it would look like this. Agree? Okay. Agree? All right, now, did we do a double divide yesterday at all? All right. My leading coefficient is 1. I'm okay with that. I always use the last 2. Now, in the past, we did divide by x plus 2. It came out to be negative 2 as my root. X plus 1 comes out to be negative 1. This guy is always going to come out the opposite way, but we're going to have to make 2 divisions here because we have 3 terms. We're going to take this one out the opposite way, which 0 comes out 0. We're going to take this one out the opposite way, so negative 1. This is tricky. We're going to do this a couple of times. If you just watch first, I'll do it again so you can write it down. If you watch, you see a better pattern. So now we're going to take out your coefficients. I have a 1 for x cubed. I have no x squared. I have no x1. And I have a negative 9. So again, we start with this, bring it down. We still multiply from left to right, but notice we have 2 things to multiply. So we start here. Just watch, don't write. 0 times 1, we go to the right, is 0. Negative 1 times 1 is negative 1. We continue to go to the right, and we stop. Then we add this guy down, the one next to me. This adds down to 0. Then we do it again, left to right. 0 times 0 to the right is 0. Negative 1 times 0 to the right is 0. Once you hit the end, stop. Add down. This I add down to negative 1. This adds down to negative 9. I'll do this again with you. Then we say, okay, x cubed over x squared, I should be able to start with x1. x1, x0. This must be my remainder. Work your remainder backwards. Start here at the x0, x1. So I write it like this. 1x, I'm going to just put the 0 in here for now, plus, here's my remainder, negative 1x minus 9 over x squared plus 1. And do I need this 0? No, so I could leave this as x plus negative x minus 9 over x squared plus 1. Okay, this is a double division. I have 3 terms in my denominator. If I have 3 terms, I'm going to get a double division. Okay, we'll do this again. So let's try this again. Okay. So again, we look like this. I'm going to just exaggerate this and put the 0x in here. So my leading coefficient is 1. Perfect. I take these 2. They come out the opposite way. 0 can't come out opposite. It's 0, right? I do the same thing I did before. I put my coefficients on the top. I have to use a space holder. So let's do this together. Bring down the 1. You're still multiplying left to right and going to the right. So 0 times 1, go to the right, 0. We got another one out here. Negative 1 times 1, well, you already went to the right, go to the right of that, negative 1. Stop. Add down the column next to you here. Do this again. 0 times 0, go to the right. Negative 1 times 0, go to the right of that. Once you reach the end, add down. So we agreed x3 over x2 gives us x1, x0, remainder, x0, x1. Yes?
In the first one, where the 0 are, the negative 1 can't go under 0.
Nope, because we have to go to the right. As we do this one first, we go to the right. Then we do this one, we have to go to the right of that.
And for the 0, but how come the 0 can go under the negative 1?
That's the next time around. Then we stopped. So then we added this column down. Now we're working with this 0. 0 times 0 to the right. Negative 1 times 0 to the right. It just keeps moving to the right. Okay? Okay, let's see if we can do these zeros.
Yeah.
These are space holders because this is x3. This is x0. So I need to fill in those so I can say 3, 2, 1, 0. I need to fill those in with space holders. Otherwise, you really are not dividing it right if you forget those other little parts. Okay, let's try the last one together. Okay, let's pull out our coefficients. 2, negative 4, negative 15, 5. So let me check. 3, 2, 1, 0. That one looks good. Now, I notice my denominator is my square. So I FOIL it out, and I get 3 terms. My leading coefficient is 1. So I look to these 2. I take them out the opposite way. They're coefficients. So I take out a negative 2 as a positive 2. I take out a 1 as a negative 1. Read it left to right. You gotta read left to right. That's how we read sentences, right? That's how we write math problems, left to right. So we're gonna double multiply this thing. Bring down the 2. Start at the left. What is 2 times 2? 4. To the right. I got another little pair here. Negative 1 times 2. Negative 2. Well, I already went to the right. I got to go to the right of that. And I stop. I did my 2. I add down the guy closest to me. What does that give me? 0. I start my pattern again. 2 times 0. To the right. 0. Negative 1 times 0. To the right of that. Negative, 0. Now, I'm at the end. I add down. What is negative 15 and negative 2? What is 5 and 0? Okay. Front end. My highest in my numerator was x3. My highest in my denominator, x2. So what should my answer start with? X to the 1. I don't really need that 0. This is my remainder. Work it backwards. X0, x1, plus negative 17x plus 5 over x minus 1 squared. Now,
Wait, why did you put negative 17x?
because that's part of your remainder.
There's an x in it?
Well, we start at the right, say that's x0, that's x1.
You do that for all of them or only when it's...
Well, when it's 2.
Okay.
Because the other one is just a plain x to the 0, which is just itself. But if we have more than one term over here, you're going to get more than one term over there. Unless one of them cancels out. But you'll get more than one term over there.
So when you have them more than one
That's
term,
it.
that's when you put x when x 0.
Yes. Yep. Okay, so that one has a little bit of difference in here. Just a little bit of difference with the divide. Okay? All right. This is not a quiz. It says quiz, but it's not. Anybody can panic.
Relax, babe.
But tomorrow, you will have a quiz that looks exactly like this.
Wait, what is this on?
This is the graphing and things like that, but I labeled everything.
Oh my gosh. No, no,
I decided to get a quiz, but I decided since I think we should do one that we can do fully. So I did a different quiz for you tomorrow, but it looks very, very similar to today's. And I thought this might help.
Oh, yeah.
What's that? Opportunity to give you something that's going to be exactly like tomorrow. Pick up your pen. This is a heads up for the quiz tomorrow. Come on, can't miss this. Okay, describe this to me. Describe this. I have an even exponent, but I have a negative coefficient. Where are my ends behaving? Down. Both down? Okay, both down. How many roots do I have?
4,
How many turns do I have?
3,
How many inflection points do I have?
2.
So you describe it before you start any of the letters?
Describe it, because you know what? You need to know what you're looking for. And again, out of that up there, can you find me the y-intercept? Remember, we like to do that to sketch as well. If I took out these x's with zeros, what would my y be? 0. So you're going to show me that you took the x's out algebraically, and you're going to show me your intercept. So now, your next step is sketch this.
Wait, can you show me how you got your end behaviors?
My end behaviors. We know that this is even, so think of your parabola. When you see x squared, it's a regular parabola, opens up, right? What happens when you see negative x squared? Where does it open?
Down.
So where are your ends going?
Downward.
Down. All your evens will behave just like your x squared. So whenever you see an even exponent, think x squared. You know that one, that one's easy. Positive, up, negative, down. So put it in your calc. We're walking this through together. Make sure it turns down. Make sure you remember to put that negative sign there. Do a Zoom 6 and start from scratch. What do I have to change on my window? Your Y what? Your Y max. So you should be able to give me a graph. And didn't we say that we should have 4 roots? 1, 2, 3, 4. There's a double in the middle. Didn't we say our ends would turn down? We would have 3 turns, 2 inflection points. Right? Okay. So let's label this. Let's find our exact intercepts. We found our y equals 0 by putting in all your x's. That was your y equals. Now we're going to find your x-intercepts when y is equal to, sorry, when x is equal to 0. When y is equal to 0. I wanted to do that first up there. God bless you. How do I factor this? Okay, take out an x squared. Can I also, did you want to get rid of your negative? Want to leave it there? That's fine. Let's take out an x squared. What's left? Negative. Okay. I can see my double root. This is my double. Okay, I'm going to set this equal to 0. Now, in order for me to factor a trinomial, I need to have a positive in front. So what can I do to get that to be positive? Factor out a -1 because I have an equation. I can divide by a -1. So what are my factors? I switched all the signs, right? Got a minus and a minus. Oops, can't be. Oops, that can't be. Oh, I'm sorry. This was a +6 over here. So this is now a -6. I rewrote this. This is a +6. This is a -6. So we knew one had to be a minus because they were both on opposite sides. So what do I get? 3 and -3 and +2. Right? Okay. So x is equal to -2. X is equal to +3. Now, those are numbers. You should see them on your table. Just take a look at your table. At -2, does it say 0? Does it say 0 at the 0 and 3 at the 0?
Yeah.
Check them on your calc. You can check that. Okay, so we found all your exact zeros. Oops, -2. There's your exact zeros. Okay, let's move along. Max and mins. I'm going to label these guys. What's A? Is it a max, min, relative, absolute?
Absolute max.
Relative
A
max.
relative max. Good. What's C? Relative min. Make sure you use the right words or you don't get credit. What's C? Absolute max. Okay, so the min, what do we know that to be? We're across the y-intercept. What was that point? That was my 0, 0. Good. So find me your max. Make sure you use second calc max. No trace. And how many decimal places do I want? 3.
Wait, how do you do it? Second amount?
Second calc max. I know this looks pretty bad up there. I'll let it go for some minutes. And find me the other one. Second calc max. Don't use a trace. Move your cursor to the left of the bump, to the right of the bump. Gotta do it twice. Gotta give me 3 zeros. Everybody come up with those? With those values? Anybody not? Anybody having trouble with the max or the min? Speak to me now. Okay. Let's move on to domain. What's the domain of this guy?
All real numbers.
All real numbers. There's no area in your table that says error. What's the range?
2.147 to -infinity.
But range are your y values, right?
Negative
Sorry.
But you're okay. Negative infinity to 16.305. 6. Now, do I put a hard bracket on there or a soft bracket? Hard bracket. That's where we're going to stop. I know we rounded, but we're forced to round to 3 decimal positions. Okay, we need to do an increasing and a decreasing. Increasing, decreasing, go off your mins and your maxes. So start at the left-hand side. What is y doing as I go up here? Increasing. From where?
Negative infinity to -1.3.
Good. To the x value. Make sure you give me all decimals. Don't round that. Then what am I doing from A to B? Decreasing. So from where to where?
-1.397
Good. Then I changed again, and now I'm increasing.
0 to 2.47.
And then I changed again, and I decided to decrease.
2.472.
Good. Make yourself a note that you need to use your x values. X interval. As y increases or decreases. Okay, so we're going to work on that. Inflection points. Inflection points go by concavity. So we look for a cave. And a cave looks like this, and an upside down cave looks like this. So eyeball this. Do we see a cave right here? Down. Where's another down? Right here. Where's an up? Right in the middle. There's an up. So look where my marks are. Wherever they cross over each other is where they had a share. So if you want to share something with somebody, you want to share it half, you want to take half. If I'm going to share my cookie with Gabe, I'm going to say, here, let me share this. And I break off a little tiny piece and give it to him, and I eat the rest. No, I have to give him half, right? So I got to find the halfway mark. We're going to call this D and E. And if you remember back to geometry, halfway is a midpoint. We're going to find the x values. Luckily, this guy is 0, 0. So we're going to take this x value to find D, negative 1.397 plus the 0, and divide it by 2. So put that in your calc and come up with 3 decimal places. So you should get negative
699.
That's a decimal, but I keep making into my negative sign. Now, in order for us to find the y, listen carefully. Go to your graph. Go second calc, you're at value number 1. Hit enter. And put in the value of negative 6.99, just like that. Negative 0.699, sorry.
This
This
is for inflection point?
is for an inflection point.
Wait, what is that?
And the inflection point is where it decided to concave down and then switch halfway and concave up, where our two caves kind of cross. So remember, an inflection point is an XY value. Good, 2.351. I'm only going to really need my X value, but I need to give me a point.
Wait, where do you have to put it?
Second calc, second the trace button, number 1 value. Now let's find point E. You guys find me point E.
Wait, so would you take the x value from C then?
Yeah, from C, which is what?
2.
And then you would take the X value from B, which is 0, divide them in half. Do the same process and find me the midpoint.
1074.
Okay, go to your calc.
And 6.829.
Very good. Did everybody come up with that point? Okay, now, concave up. Concave up. Concave down. The last section, guys. So read left to right. Follow me. I'm making a cave down. From where? Negative infinity to this x value, which is what? Negative 0.699. Good. Then I changed my mind and I decided to concave up from here to here. So negative 0.699 to 1.074. Then I decided to cave down. From where? Good, 1.074 to infinity.